Good afternoon, everyone. Thank you for joining our webinar today, Steam as a Service, presented by subject matter experts from a unique partnership between Miura Boiler Company, Hartford Steam Boiler Company, and Armstrong International. My name's Cam Spence, and I'm the Director of Educational Development for Armstrong International. From my own personal experience in the steam industry for over 34 years, I've witnessed a number of dynamic changes in the various markets. One of those changes has been around the challenges of efficient and reliable steam generation. Steam utility is clearly one of the most critical for all markets as it greatly impacts the customer's production. Yet a number of market dynamics have created system utility changes. Dynamics such as availability of qualified boiler operators, poorly maintained boilers, or end of service life for a boiler system in older plants that causes large capital expenditures, changes in production over time, or even ramp ups of new production due to something as unforeseen as COVID-19. Energy sourcing and emission requirements are ever changing. Our subject matter experts will present a new model that addresses these market dynamics and deliver efficient and reliable steam for the customer. I have the privilege today of introducing our subject matter experts. Our first is Paul O'Donnell, Senior Vice President of Strategy of Miura Americas. Mr. O'Donnell is a 15-plus year employee at Miura who is currently responsible for all strategic partnerships, special projects, mergers and acquisitions, and marketing. About 2 years ago, Paul conceived and developed the Steam as a Service concept for the U.S. market, was instrumental in creating the alliance between Miura, Armstrong International, and Hartford Boiler, three industrial leaders who will be marketing and supporting this innovation and important service. Paul holds an MBA from a leading university and has been recognized by his peers and colleagues for his outstanding achievements in the steam industry. Next up is Mark Goldleaf, a strategy and innovation for the Internet of Things for HSB. That's Hartford Steam Boiler. Mr. Goldleaf is a product development leader with experience in design, engagement strategy, and digital transformation, expertise spanning 24-plus years of agency and client-side experience. Mark leads the industrial Internet of Things engagement at HSB, helping to build customer-centric and market-leading IoT solutions for industrial enterprises. His focus is on the Industrial 4.0 production optimization, predictive maintenance, and as-a-service transformation that are custom solutions for cutting-edge risk mitigation backed by guaranteed results. Our third subject matter expert is Scott Knight, Director of Engineering and Project Development for Armstrong Service. Scott has 30-plus years of industrial operations and maintenance experience in utilities for industrial and food manufacturing facilities. This includes 15 years in cogeneration, energy, and utilities management. He's worked at plant and corporate level in utility infrastructure management, focusing on energy and utility reduction projects and programs. Scott holds a Bachelor of Science degree from Western Michigan University. He's a certified energy manager through the Association of Energy Engineers and is past president of the Kalamazoo Valley Chief Engineers Club. To kick things off, we'd like to play an introductory video.
Well, hello, and thank you all for joining us. This is Paul O'Donnell with Miura, and we have about 20 slides we're going to go through today to dig a little deeper into some of the concepts and the offering that were just presented in the video. Of course, it probably goes without saying that whether you're looking to design and install a new steam plant or to retrofit an existing steam plant, it's quite a complicated project. From design to equipment selection and procurement, financing decisions, construction, operation and maintenance. It's a broad, diverse skill set that's required to come together, pull the project together, and build steam infrastructure. In particular, and in the current market, there are three key challenges, which are really the drivers behind why Miura, Armstrong, and HSB are introducing this model at this time. First is appropriate capital. Getting access to appropriate capital for steam infrastructure is, and then probably always has been, a major challenge. There's a lot of competing demands on capital, and often infrastructure, in particular steam infrastructure, gets put at the bottom of the totem pole. So a hospital is much more likely to invest $3 million in a new MRI machine that they know they can generate revenue on day one than to possibly replace 30-year-old boilers in the basement. The second, as mentioned in the video, is challenges in the workforce. Through 1980, the United States Navy was responsible for generating quite a bit of the knowledge and experienced workforce that fed the operators, technicians, and engineers around the steam industry. But in the 1980s, when the Navy moved away from steam-powered boats to gas turbines, then they closed down their boiler technician school. And of course, we've been feeding off as an industry that knowledge for the last 30 to 40 years. As those individuals approach the age of retirement, we call it the silver tsunami in the industry. It's becoming more and more challenging for end users and customers to find capable people to maintain their plants. Both of those lead to significantly aging infrastructure and subpar efficiencies being the norm across almost all industries that use steam in the United States. People either fail to invest in best available technology because of limitations with capital, or just lack of knowledge about what new designs and technology are available. That's where Steam as a Service comes in. We have brought together what we think is a world-class partnership of three companies that are experts in the field of steam and steam generation, and have put together what we believe is a really revolutionary turnkey solution that's quite differentiated from other models that exist. In its purest form, Steam as a Service takes all of the components involved in designing, installing, financing steam facility, operating, maintain, and turns it into an operating expense, single monthly payment, all inclusive, and takes responsibility for the maintenance and operation and optimization of that plant off the customer's plate and puts it into our hands. Who better to maintain, operate, design your boilers than the people who manufacture them? For each project that we engage in, a special purpose company, SPC, is formed, and that is the single point of contact that will manage the relationship between the three key alliance members, as well as other participants like local Miura representative, service representative, local utility providers, or additional manufacturers that might be included in the scope of work. I think that's an important time to add that we are going to talk a lot about Steam as a Service today, but one of the reasons that we reached out and formed a partnership with Armstrong International and Armstrong Services is that they have decades of experience not only in steam, but also in operation and maintenance of energy systems as a whole. So if we're looking at a steam project and there are other pain points that our customers have in the same space, whether it be compressed air or nitrogen or chilled water, we're happy to look at including those in the project, developing some specific KPIs around what we would then guarantee and measure, and broadening the scope. So I'll let Scott from Armstrong talk a little bit more about that as we get to his introduction. Miura, if you're not familiar with Miura boilers, Miura is a company that's headquarters in Matsuyama, Japan. We do have manufacturing facilities in North America, in Rockmart, Georgia, and Brantford, Ontario, Canada. Almost everything we sell in the United States is manufactured out of Rockmart. Miura was founded in 1927. In the 1960s, we introduced a new small modular fast response boiler technology to the market that now has become our core product line, and the primary boiler technology in Japan and many other countries in the world. Everything that we do is modular in nature. The single largest unit we provide in the United States is 300. We have a MI control system that allows you to gang those up in 5, 10, 15, even 20 units in some cases. To maintain optimal efficiency, of course, N+1 is inherent in the modular design, and as well as unparalleled scalability for either changing seasonal loads or increases or decreases in demand as your business needs evolve. We believe that technology offers the best-in-class safety, reliability, and efficiency record. Approximately 5,400 employees globally, and currently have over 140,000 units in operation around the world. We've been manufacturing and have a robust service and representative network in the United States market for well over 30 years now. With that, Scott, are you on the call, and did you want to speak a little bit about Armstrong?
I sure will. Thank you, Paul. Again, this is Scott Knight with Armstrong Service. Armstrong was founded back in 1900 and for decades played heavily in the steam and condensate arena, but now it's expanded to hot water systems, humidification, again, steam and condensate. And back in the mid-90s, Gus Armstrong decided that there was a need for utility engineers, operators, maintenance personnel at different sites, so he created Armstrong Service. Armstrong Service is broken into two halves. One half is the engineering, the turnkey projects, product solutions. The other side is operations and maintenance. But because we stay very close to our the big A, as we call it, education and training is high on our list. We spend a lot of time. We have a STEAM, it's called STEAM University, where we cover a wide range, anything from learning about simple traps to combined heat and power. So we cover a broad range of materials. So back to you, Paul.
Great, thank you, Scott. And Mark, I know you were having some trouble, technical difficulties. Were you able to join the call? Well, let me try to introduce HSB as well. I apologize to the attendees. HSB was slated to be here, and I think Mark is trying to join. Maybe he can speak when he comes in. But most people are probably familiar with HSB, Hartford Steam Boiler. Founded in 1866, Hartford Steam is synonymous with safety and insurance, equipment insurance, and breakdown insurance within the steam boiler industry. What you may not know about HSB is that they also have robust engineering services group, as well as in more recent time, we're making a major player movement into the IoT space. With the Internet of Things and remote monitoring and sensing technology, the landscape is changing around equipment breakdown, and preventative and predictive maintenance is becoming much more important. So HSB has made about a $500 million investment into IoT space to modernize and update their insurance business. So we are very happy to have them as a partner in the Steam as a Service Alliance. Not only do they obviously provide the insurance and the guarantees, performance, reliability, and efficiency guarantees behind the model, but they also provide the IoT technology, which really enables the platform, enables Miura, Armstrong, and HSB to function as a single entity, and to monitor and optimize the steam plants that we'll be building over the life of the contract. So we talked about the three entities separately. This is the slide that really brings it back together. There are other energy service companies and energy service partners out there, but none with the pedigree in steam and steam knowledge and experience that Miura, Armstrong, and HSB have. It's really the intersection of these three companies that we believe makes this an exceptional model. With Miura, of course, providing the core technology behind the steam, the modular boiler design, Armstrong stepping in and doing the initial steam system audits and preliminary and full engineering services and design services. And then, of course, the operation and maintenance piece, which is critical. I should add optimization as well, very important part of the offering. Keeping the plant, not only building the best steam plants initially, but making sure that they are, best in class over the 15 or even 20 years of the contract term. And then, of course, offering the insurance inspections, validation and verification. We have 3 companies looking at the design that's going into these new steam plants and really trying to build, best in class, world-class steam infrastructure all across the country. Just a little bit more on project flow. Again, I mentioned that in its purest form, the steam as a service model turns steam into a utility, just as you would buy electricity or water, single monthly bill, and we take responsibility for all the steps involved in converting gas, water, and electricity into steam. There are some exceptions to this. If a customer, for instance, wanted to procure the raw goods themselves, maybe a university has existing gas contracts and uses natural gas for other things than steam generation on site, they may prefer to take that procurement role and sourcing role on themselves, and we can carve that out of the model and still provide steam as a service as a converting model instead of as a utility model. One common question is, can we do steam as a service without the operation and maintenance piece? The answer to that is no. We cannot own and take responsibility and provide the guarantees for performance, reliability, and efficiency if we aren't the ones that are taking care of and monitoring and responsible for the upkeep of the equipment. So I'll throw that out there. We can carve out the financing if somebody wanted to have the benefits of steam as a service, but they had their own capital, then we'd certainly be willing to look at that as well. Very transparently, we're happy to share our finance rate. We do think it'll be competitive. We do believe that's a primary driver of the model, but certainly willing to engage on a project-by-project basis and talk about what your specific needs are. Just to recap a little bit of the value proposition, we will be sharing a copy of the presentation after the webinar today, so I'll go through this fairly quickly and you can refer back to it. But cost savings is obviously number one, either investing in building the best available, best-in-class new steam plants, or retrofitting an existing plant to significantly increase the operational efficiency. There's savings potential, even in some cases, year one savings, even after financing the entire model. No upfront capital, I think that's been very clear. The first bill as a steam as a service project is the first month you produce steam. Reliability and peace of mind, this is really the core behind the principle. Steam as a service allows our end users to focus on their business, what they do best, and allows us to focus on what we do best. And we believe that is the way it should be. Guaranteed solution, we talked about that. I'll mention repeatedly, performance, reliability, and efficiency guarantees are the foundation of every steam as a service contract. But we also are happy to work through HSB to look at customized pain points or KPIs with the customer. For instance, maybe outside of steam generation, you're struggling with the aging condensate return system and you're getting 30% back when you should be getting 60% back. We'd be happy to add that as a project, expand the scope of work, have Armstrong's team come in and diagnose the problem, make some recommendations that we can then capitalize and take ownership of over the contract life, and HSB will then write a guarantee around that performance. In that case, taking it from 30% to guaranteed 60% return over the contract life. Just one example, but I think you can understand. Best-in-class partners. Again, there are other energy service providers out there that'll do entire projects, including lighting, insulation, windows, steam, chillers. But the 3 partners here, their core history in the company, over 300 years of history, is in steam, and we believe that's a real differentiator. And we can bring steam as a service to the market, therefore, without a middleman. So we believe that allows us to offer energy services at a very competitive price point. Modular connected technology, again with Miura being the foundation, it provides unparalleled scalability for a central steam distribution or district energy type of model too. That's exceptionally important. Sizing, of course, even a small boiler project is a major challenge. You have to size the equipment for the peak load on the coldest day of the year and then put in some safety factors. So oftentimes boilers, steam plants are largely oversized and therefore not operating at optimum efficiency once the customer goes live. A modular installation of having 8 small boilers instead of 2 large ones allows you to turn those on and off as needed and or increase or decrease, actually remove capacity as you need. Continuous optimization, that's something we should talk about around the O&M piece. Not only will Armstrong have operation and maintenance crew on site daily maintaining the boilers, but engineering staff will come to the facility on an annual basis, reoccurring basis, to continuously optimize and partner with our end users, not only on steam generation, but also to review and talk about production side and use of steam throughout the facility. And that time and those hours are included in the contracts. Transparency is something we're working very hard on. Obviously, there's a pretty detailed contract involved when you're talking about a 15-year turnkey solution. But we are working very diligently to make a very easy to understand, mutual, fair contract from both sides. I'll share an example of that later. There's quite a few examples, but we'll talk about the buyout provision, which I think is a key component of energy services. And then continuity of employment as well. I wanted to make sure that end users understand that we're not coming to town or trying to put people out of work with steam as a service. As we come into a facility and look at taking over steam generation and operations, we are committed to first and foremost looking to existing staff on site to fill those positions. Obviously, they need to meet standards of Armstrong International and engage in ongoing training. But in most cases, the majority of staffing, provided the customer wants that to happen and they don't want to relocate people, will be used in the steam as a service model. This is one, again, that usually HSB takes. Mark, have you been able to join the call yet? All right. I think I already touched on this a little bit, but we talked about some of the rationale about why Miura believes that, or why the Alliance believes that the time is right for steam as a service and energy as a service model. The 3 driving components: capital, limitation on capital, workforce, and subpar efficiencies being commonplace in the industry. A 4th one is the timing. With the timing has to do with the advancements in the Internet of Things and remote sensing and predictive and preventative maintenance technology. Again, this is really being enabled by HSB's recent acquisitions in the IoT space, acquisition of a company called Relayer as the primary platform, and some sensing technology by companies like Meshify. But it really creates a platform where Armstrong, Miura, HSB, and the customer can communicate seamlessly to have the different components and all the different features of the steam as a service model effectively talking to each other. For instance, if we had a smaller steam plant and we weren't going to staff it 24/7, the IoT system with Miura's online monitoring would send a remote alert or alarm to Armstrong staff, notifying them that there's a problem on site. We could either then do remote troubleshooting or dispatch a technician in some cases before our customers even know about it. So that's what we're talking about with enablement via IoT. I think I talked about these in detail. I'll go over them one more time. Guaranteed solution. We are providing guaranteed metrics around performance, reliability, and efficiency for all our steam as a service proposals. But then again, I want to make sure we reinforce that it's not limited to just the efficiency, performance, and reliability around steam generation. We also are very interested to talk about any other pain points around energy services as a whole that you may have been struggling with historically, that we can write specific metrics and KPIs around and then expand the scope of those guarantees. This is a little peek behind the curtain in the pricing model and what the actual invoices would look like. Obviously, I mentioned that we invoice with one single monthly bill, all inclusive. If you actually look at the invoice, you're going to have 4 pricing categories or 4 pricing components. The first is fixed capacity costs. We also call it capitalization cost. Obviously, if we're talking about a $2 or $5 or a $10 million project and we're funding that, then we need to amortize those costs over the life of the contract and in order to stay whole. That's what the fixed capacity cost is about. Fixed operation, maintenance, and administration cost. When we put the plants in, obviously we're responsible for keeping the lights on and maintaining enough staff to keep the boilers operational at any time. So there's a fixed portion of the cost every month as well that allows us to do that and to provide replacement parts, annual inspections, continuous optimization, administration, all the things we talked about. It is a truly inclusive contract. So as I mentioned, everything from a broken valve or a replacement pump to the water treatment chemicals to air filters are included. That brings us really to the next one, which is variable steam usage cost. The additional cost that is billed out based on the actual usage of the plant, that is per 1,000 pounds of steam consumed. That's a percentage, that might range anywhere from 80 cents to $1.20 depending on the operation. But that allows us to track the actual usage of the plant, to account for and bill for the consumables that directly vary with the amount of steam you produced. Water treatment is one. A big portion of that cost is water treatment. So the more steam you produce, the more chemicals you consume. And then, of course, proportional wear and tear on the equipment. The more it's run, the more it's utilized, and generally speaking, the more it's going to cost to maintain it over time. This also allows us to track our business and the billing with your productivity. So the more widgets you're making, the more patients you're serving in a hospital, then the more steam you're using and the more revenue our alliance is generating based on the value we're bringing to the table. Fourth one is easy. That's just the raw materials cost. We don't get involved in selling the natural gas. What we would do is be involved in negotiating and in many cases bringing partners to the table that could provide very competitive, attractive rates. And then should you select to have us provide that, there'll be a simple bill processing service that we will monitor, track, audit those bills, and then include them in the single monthly payment. This next one is what I referenced previously. This is just one example of what we think differentiates our energy services agreement or contract with this model. This is the buyout provision. So standard contract length is 15 years. We do offer 10 or 20 years as a standard product as well, but generally we're going to come in and provide pricing around a 15-year contract. At the end of that contract, of course, we would start talking 6 months or a year before it expires, and at that point, we hope that everything's been going well from your perspective. We've proven our ability to be on site and take over steam generation, and we'd be looking at a 3 or 5 year contract renewal. But if that wasn't the case, let's say in year 4 of the contract, your company had decided to move operations or was going through a buyout and needed to liquidate or close out all contracts, then we have a very easy to understand predetermined buyout provision that from day one, there'll be a chart included. Right here, we're showing a 15-year, but it would actually be by monthly increments, where that would be the amount that the end user would pay to take over ownership and operation of the facility. So if your business needs changed again at year 2 or year 5 or year 8, it would be a very simple matter to exit the contract and to buy out the equipment. Comparatively, some contracts you might see or you might hear of have a fair market value provision, which means that if you're on year 6 and you want to exit the contract, then each side has to go out and hire independent appraisers and try to determine what the value of the asset is at the time of termination. It's a fairly adversarial process. Obviously, it's in your interest to have a low value, and it's in their interest to have a high value. And so, you know, oftentimes it can be a lengthy and difficult process. So we really believe this is a superior way of providing buyout provision. One more time. Mark, were you able to join us yet? All right. Wanted to talk a little bit about the financial model. I am not, didn't come up through the accounting side, so I'd have to defer you back to HSB for additional questions and or your accounting people or tax people. But basically, there's a significant advantage for many customers in a Steam as a Service model because it allows for off-balance sheet financing and capitalization. So because of the new regulations of IFRS 16 and the implications, the way we've structured the energy services agreement around Steam as a Service should allow most customers to treat it as a truly operating expense as opposed to a capital expense or a traditional lease, which would be required to be shown as a liability on the balance sheet. And so in particular for any publicly traded company or anybody who's balancing the books to that level, this can be a significant advantage. I think we covered the modular design enough, so I'll skip over that. But again, the idea is that truly scalable system. In particular for customers, I'll add that have multiple facilities. With the modular nature of Miura boilers, it's easy to pick up and relocate capacity. We also will include in our energy services agreement, well, if we're going to go in and build a boiler room around an initial load of, let's say, 80,000 pounds per hour, we might put in 9 300 horsepower boilers, but we would leave room for 3 more in case at a future date your production or your requirements or you had a building expansion and you needed more steam. At that point, it's very simple to bring in capacity. Or similarly, if you wanted to relocate capacity from one facility to another, then we can remove those individual units, make a very simple line item adjustment to the monthly contract, and transfer that steaming capacity, either between existing end users or even across end users by providing a pool of boilers that we can use and still fully guarantee that may be lightly used. Scott, I've been talking for quite a while. Did you want to take this one and talk a little bit about the project flow?
Sure, I sure will. Yeah, typically what we'll do is after we present to a client, what we really need to do is have agreement between the Steam as a Service team and our client. And that means we have to agree on what the scope of the project looks like, what the equipment, what's in the project, what's out of the project, and also, interestingly enough, what they are actually currently paying for their steam. A lot of folks might say, well, my steam costs, $5 per 1,000. Well, are you thinking about the benefits and annuities of your operators? Are you thinking about your capital costs for repairs? Are you thinking about all these different things? And so before we get too much down the road, we want to make sure that we're both comparing apples to apples. And to do that, what we do is we ask them to sign a letter of interest. It's non-binding, but it just gives both parties information about everyone's willingness to work together to come to agree on a common goal. Once we do that, we look at providing an energy audit and system review. That way we can get a good idea of what the existing equipment looks like, how it's being operated, what condition it's in. From that, we can start to determine what the actual overall cost is, and again, get agreement with the client. From there, we look at a preliminary proposal and recommendations on you know, you want us to do X, Y, and Z, and we think this is the path to get there. Once we kind of have agreement on that, we'd like to come in and do an additional site visit, and we can just do a little bit deeper dive. Once we get to that level, we're going to start looking at putting out some engineering time, some design work, and at that point, what we try to do is get a letter of intent, and that is a binding preliminary engineering development contract. And what does that mean? That allows us to bring in, if we need to bring in some field experts, that's possible, but we'll go a deep dive, and when we come back, we've got a pretty good idea of what that turnkey solution is going to look like. And when we're done with that, since we've, with the letter of intent, our client has paid for it, that report is theirs. That is not kept confidential with the Steam as a Service group. That is given back to the client. I mean, they paid for it. It's their property. They get it. After that work is done, we validate again with the client that the preliminary engineering meets what they're looking for, that all of our goals and standards are being met. From there, we go to the contract signing, and after that, we just break ground and we start building the new plant. Paul, back to you.
Yeah, great. Thanks, Scott. I think the next one.
I'm sorry. There is one thing I wanted to add. Oftentimes I get asked, well, what if the company already has an engineering firm that they prefer to use? We are very flexible to work with existing engineering firms or A&E firms that work at the site. In fact, in some ways, it makes it easier for us because those folks actually know the personnel, they know the plant, they know the area, and a lot of times that's very beneficial. So I just wanted to add that. Thank you, Paul.
Great. Thanks, Scott. Stay around if you would. I think this next one is yours as well.
Oh, sure enough. And again, we talked about the different levels of engineering and audit. And again, the pre-assessment is we go in, it's a very quick hitter. We're looking at ECMs, which stands for energy conservation measures, along with everything else that has to do with the Steam as a Service. And what do I mean by that? It's quite easy to go into a power plant and say, okay, here's your boilers, they're this old, they're in this condition, your deaerators, so on and so forth. But we also walk the entire plant because it's very short-sighted to just concentrate on the boiler room when some of the major issues might be in the process, it could be in your condensate system. So not only do we want to look at the boiler room and look at the Steam as a Service project as an individual, we want to get a holistic look at the entire facility, and that's something we provide. And again, part of that auditing process is reports, energy conservation measures, and we break it down to, problem, issue. Here it is. This is the problem. This is why it's a problem. We describe it, or we use a diagram or a photo, and then we give our recommendations that, if this is the problem, this is our recommendation to alleviate that problem, and we give you the savings, plus or minus 10% based on standard fuel cost, and along with an investment, if it's out in the plant, of about plus or minus 40. We can usually do better than that, but we like saying we can get you in the ballpark. And so with that, again, not only do we want to look at the boiler room and the utilities, we also want to go out in the plant, make sure those are operating as optimally as possible. The basic design study, again, we're going to be going through the plant in detail. Oftentimes, at the surface, our clients will say, it's our, this piece of equipment is the bad apple. It's the one that's causing us all the problems. Well, as we start looking at basic design, we start looking at the engineering behind it, we might say that actually it's the piece of equipment previous to it. I mean, we've found many applications when if, we'll have a piece of equipment that's not functioning or is causing issues, it's actually the equipment before it that's feeding it that's the problem. And so by doing a basic design study, doing a deep dive on all the equipment and operations, we can solve those problems. But again, at this time, with the basic design, we're going to be looking at what are the controls going to have to look at, what is the layouts going to have to be, what kind of permitting is going to be required? Is this going to change the Title V or the small synthetic air permitting? What about the local utilities, like the water service, the electrical contracts, that's when we start going through and doing a much deeper dive just to make sure that we haven't missed anything. And again, once we come up with that, we can get the firm savings and investment at plus or minus 20. And that's what we're talking about as part of the letter of intent. That's typically, depending on the project, going to be between $50,000 and $100,000 to complete the basic design study. With that agreement, and we get the contract, then we go into detailed engineering design. And as most people are aware, this is a full contracted, all the drawings, all the permits, everything that you would normally get basically in a greenfield site. So, and you can read through there, you know, from soup to nuts, from breaking ground and permitting all the way to startup, commissioning, and those items. So, Paul, back to you.
Thanks, sir. And we'll conclude, I think, with this slide here, just to recap a little bit. You know, why Steam as a Service? Why are we on this webinar? We talked a lot about subpar efficiency being the norm, you know, in the steam industry nationwide. So I'm sure we're all aware of facilities that are running technology or boilers that are 30, 40, even 50, sometimes 60 years old, which is truly remarkable. Even with typical plants that are maybe 25, 35 years old, those facilities are probably running at an average operating efficiency of somewhere between 68 and 74%. If you look at simply replacement with a high efficiency boiler, that would not just be Miura, but any, let's say, modern, you know, new technology with a stack economizer steam boiler, you'd be able to get up to the 80 to 84% range and generate, in many cases, double-digit savings. If you really looked at investing in a top-of-the-line system with maybe additional heat recovery or a condensing system, then you can be talking about 86 to 90%, you know, final or operating efficiencies even across the system, or the steam generation system, when we say that, and you know, yield savings of 15, even up to 20% at times. So there's a lot of opportunity to not only enhance reliability, performance, but also the efficiency and generate cost savings. With that, again, I wanted to thank you for your time. Appreciate everybody sitting in on this webinar today. I think we have some Q&A scheduled. Not exactly sure how that's going to work, but maybe Jamie can fill us in, or we can take questions now. Scott, are you there with Kyle? And will we be seeing questions, or how will that be handled?
Paul, I'm not seeing any public questions, but maybe you guys should check your individual questions and answer section and see if someone sends them directly to you.
Great. I'm not 100% sure I'm doing it right, but if I am, I'm not seeing anything at this this time. Oh, wait, there's some in chat, I think. Yeah, we have a question from Tammy, I think, that said, if we are replacing an existing boiler system, do you try to get any energy or utility energy credits to help reduce the cost? The answer is absolutely yes. So, you know, after we execute a letter of intent and we're moving forward together, we will explore local utility energy credits and also bring in some additional resources to explore that with us as well, to see if we can bring those to bear, working with the customer, of course, the end user, to provide added value to the project and help get it justified and off the ground. Thank you, Tammy. All right, Scott, I'm seeing one here from Ferris Rashid. Can you provide some information about Armstrong Steam University? Does it award a certificate, location of it, and is it available online?
Yes, SteamU is available online. There's many different classes. Some of them are, depending on the level of the classes, some are free to the public. Others are part of a paid-for service. They are accredited with CEUs, depending on what class you're taking, and it's an online university. You can go to Armstrong International, and from that website, you can go to STEAM University, and all of the classes and all that will be broke down for you.
Great, thank you, Scott. Another question from Ferris. Which party is providing financing? So great question. I should have mentioned that already. Financing is primarily going to be coming from HSB side. HSB is a wholly owned subsidiary now of a company called Munich Re, which is one of the leading insurers in the world, actually globally. And they are putting together a significant, I'd say, robust financing pool for not only Steam as a service, but for equipment as a service projects. So I'm happy to engage again after the webinar and rope HSB in for any further discussion about financing. Let's see. I have another question from Joe. We are carbon neutral and lead with a biomass boiler and natural gas backup. Do you deal with biomass as well? So great question. The simple answer, Joe, is right now Miura specifically doesn't do significant amount of work in biogas. Most of the product line we offer in the United States, we don't support or promote burning biogas through it. That being said, we are certainly willing to look at other available technology. If it was a small amount of blended biogas, it may be something we would even talk about through the Miuras, but we would be willing to look at sourcing or partnering with other manufacturers to provide waste heat boilers or, for instance, condensing economizers or equipment that Miura doesn't manufacture. So certainly be happy to talk about it, but hopefully that answers your question. Scott, here's one looks like for you from Ferris as well. Maybe you answered this at the end, but do you do energy audit to the site to look at opportunities to save gas, like switching some load from steam to hot water before you start new installation of Saas?
Yes, that's actually part of the process to right-size the new boiler room. We've been at sites that have a great deal of hot water generation, and actually by updating their hot water systems, we were able to reduce the number of boilers needed, and of course, the steam flow, reduction in pipe sizing, so on and so forth. But that's part of the audit as well, to look at other areas where that could be included as the Steam as a Service offering for upgrades or improvements throughout the plant.
Yeah, great. Well said. Yeah, on many of the projects that are active for us right now, we have looked at taking some of the steam load and converting to hot water products that may provide more advantage. Even though Miura doesn't manufacture those products, we are looking for the best total solution for the customer on site. So yeah, I think that's well said. Mitchell has one here. How does the Steam as a Service in-service time compare to the traditional conventional model? Scott, help me with that one. Did you, in-service time, how do you read that?
You can either look at, the way I've always read in-service time was how you balance the boilers. And that's what's nice with the Miura units. You can get them to automatically hour adjust, which means that, let's say you have 3 boilers. Number 1 is the lead. Number 2 is your hot backup, and 3 is off. And it might run that way for 24 hours. Then number 2 takes the lead. Number 3 is your hot standby. Number 1 is off. And that way your in-service time is balanced across all the boilers. At least that's how I read the question.
Yeah, great. Thank you, Scott. Mitchell, if we didn't nail that, if you can resubmit or send another one in clarifying, but hopefully that answers your question. Or we can follow up with a separate question offline. Another question here. Yeah, I think we have 6 minutes left still. So from Ferris, sorry, I think I went back too far. Let me get back up. Does the owner take over the operations at the end of the contract if not renewed? What is the difference in cost difference to the owner if the contract is renewed? So the answer, I think basically there, Ferris, is yes. At the end of the contract, at the end of, let's say, 15 years, if it was a 15-year contract, there's a decision point. First is to renew the contract. Obviously, you said if it's not renewed, then the customer has two choices. There'll be a small residual value on the equipment that would need to be paid off. It was in a lease-to-own situation. So on a $5 million project, I think at the end of 15 years, there could be $300,000 or $400,000 left. So the customer has the choice either to ask us to, remove the equipment or abandon in place, or to pay off that small residual value, remaining value, and to take over operations of the facility themselves. So if you wanted to do that and you wanted to operate it from then moving forward, you just pay the small residual value and you would assume ownership, or basically be buying then the steam plant at that time at the end of the contract. Great question here from Ferris as well. What commitment is required by the owner in the letter of intent? So there's really two. The letter of intent commits us to putting significant resources on site, obviously, to develop and flesh out the project and do basically preliminary engineering work. So there's a monetary guarantee. It might be, as Scott talked about, let's say $75,000. So how that would work is you wouldn't pay any money up front. There would be no invoice generated with the signing of the letter of intent. But at the end of the 60 or 90-day period, you would then see our final contract and our final proposal with a guaranteed price over the contract life. And you would decide then to either proceed with steam as a service or to possibly put in the equipment yourself and do traditional ownership and operation. If you proceed with steam as a service, that money is never invoiced. It just becomes part of the contract. So there's no payment until you have your first month of operation. If you decided to take the design and either not do a steam project for some reason, or to do traditional equipment installation and customer operation and maintenance, then you would pay the money for that preliminary engineering. The other thing is during that period, that short period, typically anywhere from 45 to 90 days, typically 2 to 3 months, it would commit the customer to be in exclusive negotiations with our alliance as well. So again, we're going to be devoting a lot of resources and time and energy and coming out and communicating with you about the business model. And we'd ask for the opportunity to work that out until we submit the final contract for your review before discussing the project with any other entity. Let's see. Jeff Hicks here. Not sure if you can see my earlier question. Did you say that you will use local talent to operate? Yeah, so great question, Jeff. Generally speaking, when we go into a facility that has an existing steam plant, we are going to, Armstrong is going to first and foremost look to the existing operators on staff to, Scott, did you want to take this call? Sorry.
Sure. No, that's fine. Yeah. Typically, historically, Armstrong O&M sites have hired over 50% of their crew from the existing customer team. We need to understand, though, that there are some clients that don't want that to happen. They would rather keep all of their employees in-house. But typically, for many, it simply means, one day they're wearing one T-shirt, and when they come in the next day, they're wearing a different T-shirt. Now, with that, though, we do provide additional training. We pride ourselves in our operation maintenance and our educational levels, our licensing, and so we do require additional training. Again, our operators have to take so many hours of STEAM University every year. So again, but that gets a little bit beyond what your question is, but we prefer to keep people in-house that have experience with the plant, that have a history with the plant. It just works at best for everyone involved.
Great, thank you, Scott. And the other way to read that may be, what if it was a greenfield site? Are you going to bring people in from out of state or higher?
Well, sure, thank you. Interestingly enough, we just had that happen. We just built a new plant down in South Carolina, greenfield site. And so what we've done is the site manager at that location actually started out as an assistant operator in our Muscatine operation, ended up working at 4 or 5 different sites, going through higher levels of education and higher levels of management. And so now he is the site manager. In fact, he's the area district manager. We brought him in about 6 months before the power plant began. We hired locally. We had our various criteria for our crew, and then we onboarded our crew about 2 to 3 months before the plant began, and they had to run through all of the STEAM University classes, different training, operational training, maintenance training, and that way we also had them there to participate in all the startup commissioning. So yeah, we hire locally. Again, that just works best for everyone involved, but we do really stress our training to all the individuals.
Great, thank you, Scott. I think that we were scheduled to run till 3, so it is now officially 3 o'clock. Jamie, are you there? I'm happy to, stay around.
Yeah, I'm here. Don't worry about the time. You have a lot of great questions that are queued up. If you guys want to keep on going through them, and let me know if you can't see them as well, I can help you.
Yeah, great. I now see the Q&A populating, so I'm good to go another 15 minutes if you're good, Scott.
Yeah, go ahead.
Great. Let me just jump in here to I see a question here under the Q&A now, so kind of changing gears, that says, has there been anything done in regards to the Canadian market? The answer is yes. We are actively, in fact, engaged in a project with a hospital system. I think one of the gentlemen asking questions is from that group. But we are currently proposing and looking for STEAM as a service opportunities in the Canadian market as well. Both Armstrong, Miura, and HSB all have active and strong, robust operations there. So happy to look at projects in Canada. Great question here to maybe Andre, I think. Is there a minimum boiler horsepower needed for a project? The basic answer is yes, and we are looking for projects that involve 1,500 horsepower and above to justify the model on site and the financing level. I say generally because we are willing to adjust that down. We're working with a hospital group, for instance, right now in North Carolina that has 4 hospitals all in need of boiler replacements. The average size of each one is probably 400 horsepower. So it ranges from 3 to 6, I think, at the 4 sites. So they don't meet that threshold. But we're looking at a single contract for those 4 facilities because they're in close proximity to each other. So there are some exceptions to that 1,500 horsepower offering, but we'd be happy to discuss it on a project-by-project basis. Additionally, if it was, let's say, an 800 horsepower boiler load, but there was also chilled water or compressed air or other energy services on site, or process side steam requirements that we can justify the O&M piece for. We really need to justify the financing and also putting somebody there at least 40 hours a week. Scott, did I capture that? Anything you wanted to add?
No, you did a very good job.
This question, Scott, I might need your help with too. Do you have supercritical boiler? Any experience with supercritical boiler? How would you define that?
Yes, typical supercritical is anything over 700 pounds and 700 degrees. So that's kind of out of the wheelhouse for the Miura boilers. they don't have a superheated boiler. I don't want to talk about details about Miura, that's Paul's, but there's also a question about can this be part of a combined heat and power? Again, you could, but with pressures limited to 300 pounds, you really don't get the throughput on a turbine to be able to push enough through it to actually make it viable, unless you're spinning a pump turbine or something along those lines. But for electrical generation, the numbers don't work very well. But supercritical is typically defined as 700 pounds and 700 degrees, so that doesn't apply here.
Yeah, great. Thank you, Scott. Yeah, and I would just add that, generally, Miura, of course, operates up to 350 PSI now, so we don't generally get involved with cogen. But if there was a hybrid plant, we're working and proposing steam as a service right now to a large brewery that has some cogen on site, but then they also have a fairly large traditional low pressure steam demand. And because of that, we are willing and looking at a project that may take over both sides, and then partnering with Armstrong and our alliance to look at the cogen side as well. So we certainly would entertain that discussion and like to have further follow-up.
I did see one question about solid fuels. Miura boilers can be natural gas or fuel oil or propane, but correct me if I'm wrong, Paul, you don't have anything that can actually do coal or any kind of pulverized material. Is that correct?
That's correct.
Okay.
Or, wood chips. So again, perhaps if it was a hybrid plant and they had some of both, but if it was just solely a solid fuel project, probably we wouldn't be the best choice.
And that kind of brings up another point. We're working with a client in New York State where they need to expand their boiler room, but they don't want to. They have two existing boilers that have been recently rebuilt, but they need additional boiler output. So we're looking at the steam as a service to not only add additional Miura boilers to their site, but the long-term contract would include the existing boilers. So again, we're fairly flexible on what we can accommodate when it comes to, how we fit into each client's individual needs.
Great, thanks, Scott. Next one I have here is, do you have steam quality indicator as an IoT device? Maybe you can take that one, Scott, as well. I think the steam quality sensor Armstrong has could easily be tied in, but I'll let you maybe.
Yeah, I wish I knew the details on the communication that we do have steam quality devices. We do a lot of that for different pharmaceutical applications. I am not well versed enough to give a direct answer when it comes to can it be done on IoT. With all the different sensors and outputs on the system, I don't see why it couldn't be. But that's a good question. I'll find out.
Yeah, fantastic. Yeah, how is the local Miura rep involved in the projects? That's a fantastic question as well. I probably should have qualified that. Miura brings the product to market primarily through manufacturers' representatives. In fact, our tier 1 representative is called a Miura partner, and we consider them, part of the Miura family, so to speak. So when we talk about this being an important alliance between Miura, Armstrong, and HSB, we include our manufacturers' representatives in the Miura statement. And our local reps, where we have local reps that have service capabilities, which is the majority of them, they certainly will be involved on site. Armstrong's team would be performing what we call operation and routine maintenance. But any of the heavy lifting or the annual inspections even, we'd be planning to bring our partners in to really get a second set of eyes and to work together in partnership with Armstrong. So local representatives also would still be involved on the sales side and working with the customers. They're part of the local community. It's a very important part of this project, and having somebody on site or backup if you need to call somebody in the middle of the night. So our reps and our partners will certainly be involved. If a plant needs to add, next question from Mike, if a plant needs to add 30% more capacity is the existing equipment become part of Steam as a Service? So Mike, the short answer is we're certainly willing to look at that and take over operations and maintenance, of course, for the existing equipment. Depending on the age and a preliminary audit, we may have to have an exclusion to the performance or reliability or efficiency guarantee. That's something we have to talk about on site with HSB, but certainly we will write a contract around a plant that has some existing capacity and also some new capacity. And the O&M piece and taking over, operations and performance criteria and, KPIs is something we're actively looking at as well. Scott, anything to add on that?
No, Paul. Again, that's kind of the situation we were at with the plant in New York State. Was recently rebuilt and add capacity. And again, we were going to go in, or we're going in with HSB to determine, what's the health of the existing systems. And then it's actually truly up to HSB on what they consider, acceptable risk and how they can write a policy around all of that. Or like Paul said, in the worst case scenario, there may have to be an exclusion on it.
Great. Next question here is from Jim. Can you talk about condensing economizers with Miura with an example? So Jim, for now, I'll just say that we definitely are able to quote or include condensing heat recovery on Steam as a Service projects. Miura won't be manufacturing that, we'll be outsourcing it, but we're quoting them on quite a few of the projects, and then can be increasing the efficiency guarantee or the baseline, the threshold for what we can guarantee support. Regarding your question about specific examples, or if it's more detailed about how that interfaces with Miura's first stage economizer, let's take that offline, or I'll follow up with you after this, after the webinar. Scott, maybe I'll pass this one to you. I think I'm going to struggle with it here. From Tracy, if there are existing challenges with wet loads in the CSR, oh, it just went away. Sorry, Scott, do you see that question?
No, I'm still looking at the ones in chat while you're in Q&A. So I haven't been looking at it. Sorry.
Sorry, I don't know. The list just updated. I apologize. We are committed to answer all these questions after the webinar and then publish the results as well. So I'm sorry, I don't see that question anymore. So, but we will get back to you. Will the slides be shared? I believe the answer is yes. From your side, I think we're okay with that. Probably won't want to send them directly to our competitors, but by and large, yes. Scott, have you talked about that from Armstrong's side?
I'm sorry, I was trying to get the other questions up. Could you repeat that, please? I apologize.
Question was, will the slideshow be shared after the webinar?
There will be a recording of the entire webinar, so you could not only get the slides through the recording, you could get the entire presentation.
Yeah, great. So I think the answer is yes, but we'll confirm. I found the question again. So here you go, Scott. If there are existing challenges with wet loads in the CSR department, how is this addressed? And under the Steam as a Service model, do you assume the risk for any unavailability clause?
Yeah, we've talked about that before, and it all comes down to, with HSB and us providing the operation and maintenance, as to what level of quality and what level of uptime you're looking for. Some clients require, 99% uptime with a 99.5 steam quality. So when you talk about wet steam, just so everybody understands, the drier the steam, the better the quality. So what you're talking about is wet steam. Certain pharmaceuticals and other clients that we deal with, they need 99.99% dry steam. And again, I've talked to HSB about this, and they are willing to write those kind of guarantees into the system or into the contract as long as we put the proper equipment in place and we have the proper operations in place.
Yeah, definitely, most assuredly. Okay, yep. Yeah, we have a project right now that involves steam quality is the #1 concern. It's for off-site sterilization at hospital industries, and we definitely confirmed last week that we'd be willing to write the guarantee around that. We might put in some additional equipment, monitoring equipment from Armstrong.
Correct.
We will work that out in the engineering phase. And then unavailability clause is really going to be part of the standard. But as Scott said, the initial contractor proposal by HSB generally includes a certain number of hours per year, very minimal number of hours, but it might be 99.9% then uptime or 99.2%. But we can dial that in based on your needs. Of course, it at the end of the day affects the cost. Appreciate it, Dave. Thank you for the feedback. Does your boiler have facility for automatic blowdown controller? I think the answer to that is yes. We have our surface blowdown is already automatic or as standard, and then we do offer a automatic bottom blowdown option that we include generally where we're allowed to. I think there are some code restrictions in certain areas that have prevented that in the past, but I think the answer to that is yes. Anything to add, Scott?
Nope, I think you hit it on the head.
I think with that from my side, I'm going to have to bounce, Scott. I certainly appreciate it.
Yep.
Do you want to keep going, or we want to end it there now and then commit to?
Right, I think we'll end it now, and then we'll gather all the questions and make sure that we've responded to those and get those back to everybody.
Great, thank you so much. And personally, again, thank you for attending. I don't know, Cam, were you planning to close, or Jamie, or anything to add?
No, all I would add, there will be a follow-up email to all who attend. Even if you have some colleagues that missed today's session, we will be emailing everyone who registered for this session a recording of the webinar. We won't be sending out necessarily the slide deck, but the recording inclusive of the Q&A session will be included. So just reach out if you guys have any more questions.
Fantastic. Thank you all. Have a lovely day.
All right. Thank you, Paul. Thank you, all the attendees. Thank you, Jamie, for all your help. I appreciate it. And y'all have a good rest of your week and a good weekend. Have a good one. Bye-bye.
Before you guys shut down, I just want to make sure we collect all of these